Everyone thinks a rainbow is a distant arc in the sky. They are wrong. Everyone thinks a rainbow is a distant arc in the sky, a beautiful, fleeting phenomenon to be admired from afar. But what if I told you that a rainbow isn't out there at all? That it's actually a deeply personal, ever-changing optical illusion, existing only for you, and only at a very specific moment. It's a curious thought, isn't it? We've all seen them, these luminous bands of color stretching across a rain-kissed sky. But have you ever stopped to consider why they always appear as an arc, never a full circle? Or why you can never quite reach the end of one, no matter how fast you drive? The answer lies in the fascinating, everyday physics of light, water, and our own unique perspective. It's a story of refraction, reflection, and something called the rainbow angle, a precise geometrical relationship that dictates every rainbow you'll ever see. To truly understand a rainbow, we need to strip it down to its most fundamental components: sunlight and raindrops. Imagine a single ray of white sunlight, a blend of all the colors of the spectrum traveling through the air. When this ray encounters a tiny, spherical raindrop, something magical happens. The light doesn't just pass through, it bends. This bending is called refraction, and it occurs because light slows down slightly as it moves from air into denser water. Crucially, different colors of light bend by slightly different amounts. Violet light bends the most, and red light the least. This phenomenon is called dispersion, and it's what separates white light into its constituent colors, just like a prism. Once inside the raindrop, the dispersed light travels to the opposite side. Here, instead of exiting, some of it reflects off the inner surface of the drop, much like a tiny mirror. This is called internal reflection. The reflected light then travels back to the front of the raindrop, where it refracts once more as it exits the water and re-enters the air, now heading towards your eyes. It's a precise dance. Refraction, reflection, then refraction again. But here's the critical piece of the puzzle. For a rainbow to form, the light must enter and exit the raindrops at a very specific angle relative to your eye and the sun. This angle is approximately 42 degrees. Imagine a line drawn from the sun through your head and continuing into the distance. This is your anti-solar point. The rainbow will always appear centered on this point, with an angular radius of about 42 degrees. So when you see a rainbow, you're not seeing light from all the raindrops in the sky. You're only seeing the light from those specific raindrops that are at exactly the right 42-degree angle relative to your eye and the sun. Because of this precise angular relationship, the raindrops that create your rainbow form a circular arc in the sky. Any raindrops above or below that specific angle won't send their dispersed, reflected light to your eyes. This is why the rainbow is always an arc. It's the segment of a perfect circle defined by that 42-degree angle. The lower the sun is in the sky, the higher the arc of the rainbow will appear. But why don't we see a full circle? The Earth gets in the way. The horizon blocks the lower part of the circle. Unless you're in an airplane or standing on a very high mountain, your view of the full circular rainbow is obstructed. Pilots and mountaineers, however, often report seeing full circular rainbows, sometimes called glories if they are around the plane's shadow. It's a breathtaking sight, a perfect ring of color, only visible from above. This also explains why you can never chase a rainbow. As you move, your perspective changes. The raindrops creating your rainbow at one moment are no longer at the 42-degree angle the next. New raindrops continuously move into position to form the rainbow for your new location. So, the rainbow you see is entirely unique to you, to your position, and to that precise moment in time. Think about that for a moment. Every rainbow is a singular, personal experience. No two people ever see the exact same rainbow, even if they are standing right next to each other, because their eyes are in slightly different positions. Sometimes, you might even see a secondary, fainter rainbow appearing outside the primary one. This happens when the light undergoes *2* internal reflections inside the raindrop, instead of just one. This double reflection results in the colors being inverted in the secondary bow, red on the inside, violet on the outside, and it appears at a slightly larger angle, around 50-53 degrees. The next time you see a rainbow, take a moment to appreciate this intricate dance of light and water. It's not just a pretty picture. It's a profound demonstration of physics at work, tailored specifically for your eyes. From the bending light in a tiny raindrop to the vast arc across the sky, every element comes together to create that fleeting, personal spectacle. It's a reminder that even the most common natural occurrences hold layers of scientific wonder. So next time the sun breaks through after a shower, don't just look asterisk at asterisk the rainbow. Understand it. It's a personal gift from the universe, a testament to the elegant rules that govern our world, existing just for you. Discover the surprising science behind why your coffee tastes better in a ceramic mug.